Today we were talking about, I will be brief in that, we were talking about diuretics that day. So in diuretics, I told you that blood-brain barrier. At the blood-brain barrier, say this is the blood vessel. Okay. So in the blood vessel, this is the map of cells. So the map of cells, that means we will show it something like that. Okay. Let's say these are map of cells. Are you getting it? ह्या सेल्सच्या बनलेल्या आहेत. So say here every cell, I will show it by, say for example, this is by blue line, this is by, it will not be that compact. Okay, the inner layers epidermis is going to be going to be compact. Now look at for vessels. So in blood vessels, the cells are the blood doesn't get out of the blood vessel easily because the cells are very compact. But we know that during the process of inflammation or during the this form, this is generally something or the other oozes out from the blood vessels. Why this oozing out is there? This oozing out is there because these junctions are not very tight. Okay. Now, if they are not very tight, that means what? Okay. That means depending on the organ in which the blood vessel is present, there will be the change in the permeability of the blood vessel. The blood vessels in the liver and the blood vessels in the kidney, this will be highly permeable. The blood vessels in the CNS, this will be highly impermeable. Okay, so when they are present in the cell membrane, what happens is that these junctions are very tight junctions. These junctions are not loose. The fenestrations, the windows are not there. And another thing is that when we have this blood vessel is present in the CNS, it is surrounded by the microglia. It is surrounded by the dendrons. It is surrounded by the axons of the neurons. Okay, so microglia or glial cells, astrocytes, these are the supporting cells, and neurons are the actual active cells in the brain. So there will be surrounding by all these things are lipid in nature. Now, if you see something gets out of this window, if something oozes out of this window, leaks out of this window, then what will happen? There is the layering of lipid here. These are made up of lipids. These all astrocytes, ganglions, and melanocytes, etc. These are made up of lipids. So what will happen? That when something oozes out of that, it will face the hostile environment. It will face the hydrophobic environment. So immediately that thing will again come back. So what you call it as the same membrane, the blood vessel in the brain is highly impermeable. So this system is called as blood-brain barrier. So there is nothing like the barrier to be shown. There is no anatomical barrier, but this will be called as blood-brain barrier. And because of this, the compounds cannot, or the drugs cannot easily enter into brain. There will be only one possibility when the drug will enter the brain, when it has high hydrophilicity. That means it is hydrophobic in nature, so automatically it will try to get away from blood, and when it oozes from the blood, it leaks from the blood, there is an environment which is friendly to it. Okay, that friendly to it, that it is a lipophilic environment. So we have the compound which is lipophilic. Here the compounds which are not lipophilic cannot cross blood-brain barrier. Whereas in case of venous system and lymphatic system, the blood vessels are highly permeable. Okay, the blood vessels are so permeable. In fact, that blood vessels, the cells in the blood vessels of the kidney are a little bit modified. So if we see that it is not made up of, suppose we show that this is the blood vessel and it is shown by number of cells. What happens in kidney is that it is whole will be made up of one cell, and not only one cell, it has a big opening here. Okay, so the cell is something like this and it is forming a big opening here. So these cells, these specialized cells are called as podocytes also in case of renal system. Now these blood vessels, where are these? So when you look at kidney, then what you see that that in the kidney we have the afferent, we have the incoming blood vessel and we have the outgoing blood vessel. We are not talking about these blood vessels. Okay, which blood vessels we are talking about? These blood vessels go inside and go on dividing, and after division we get a fine capillaries of these blood vessels. Now these fine capillaries, where these fine capillaries are present, so in this kidney, what you get is that when you say that this is kidney, you will call it as the upper portion, you will call it as a cortex, inner portion you will call it as a medulla. Okay, so what you get is that in the in this this whole unit, this kidney is, if you go on dividing it, you will get that smallest portion is, say, it we call it as a nephron. So nephron is made up of Bowman's capsule. What this Bowman's capsule is, again it is nothing but made up of cells. So it is a tube. Okay, it's a tube made up of the cells. Now in this you will get that here you will be having the entry of blood vessel. So it will be afferent, which is coming, and this will be efferent, which is going out. The diameter of efferent is always less than diameter of the afferent, which is coming in. Diameter is more. Efferent diameter going out is the vessel going out is less. So what happens is that here it will be generation of pressure. Okay, जर तुम्ही एखादा पाण्याचा पाईप घेतला आणि त्याला दुसरा पाईप जोडला, एखाद्या येणाऱ्या पाईपचा डायमीटर जास्त आहे, जाणाऱ्या पाईपचा डायमीटर कमी आहे, तर काय होणार? प्रेशर जनरेट होईल. सो दिस प्रेशर इज युटिलाइज्ड फॉर फिल्ट्रेशन. त्याच्यामुळे काय होतं, which is there in blood, it will be filtered here in kidney. It will be filtered here in nephron. Okay, now see this filter. Now if you see that here you will have that, I will call it as a distal proximal convoluted tubule. After proximal convoluted tubule we get the loop of Henle. Okay, so loop of Henle, what you will have, it will be having loop of Henle will be something like this, and then here you will get the bigger portion. So I will call it as a thick. Okay, this is thick one, so I will call it as a thick ascending loop of Henle. Till this it is the loop of Henle. So it is a thick ascending loop of Henle. This is descending loop of Henle, thin descending loop of Henle, and then if you go further, then you will get here the convoluted tubule, but this is away from this, therefore it will be distal convoluted tubule. Then here it will be collecting ducts. Okay, now what I will call it as a, I may say that this portion up to this portion is present in the cortex. So we will call it as a cortical portion of nephron, and then we have the medullary portion of nephron. Okay, so the collecting ducts can be described in two ways. One will be the cortical portion, another will be the medullary portion. Okay, त्याच्यामध्ये काही फरक पडत नाहीये, फक्त कसं आहे, मेडुला मध्ये सगळं तुमचं या कलेक्टिंग डक्टचं जाळं जास्त असेल, आणि इकडे काय असेल तर बाहेरच्या पोर्शन मध्ये काय असेल तर Bowman's capsule, proximal convoluted tubule, loop of Henle, etc. Now where the molecules are acting, there will be drug won't be acting on the Bowman's capsule, acting on proximal convoluted tubule. Okay, yes, it will be acting there. So what is the drug acting on proximal convoluted tubule? So we have the compounds which are the carbonic anhydrase inhibitor. Okay, so we have carbonic anhydrase inhibitors, glutamine molecules, they will be acting here. Then we have compounds which will be acting again on proximal convoluted tubule, but not limited to that. It will be on the others also. That we will be calling it as a osmotic diuretics. Okay, osmotic diuretics, mannitol and others. Then you will be having compounds which will be acting on loop of Henle. Now loop of Henle, especially the thick ascending loop of Henle, those will be, from the name itself, it will be loop diuretics. Then the compounds which will be acting on distal convoluted tubule, those will be thiazide and thiazide-like diuretics. Compounds acting on cortical portion of collecting ducts, those will be aldosterone antagonists, for example, spironolactone, and you have another one, triamterene and amiloride. These molecules will be acting there. So these are the sodium channel pluggers, whereas aldosterone, spironolactone is an actual aldosterone antagonist. And then you will be having the molecules which will be vaptans, vasopressin antagonists. Those will be acting on the lower portion, the medullary portion of collecting duct. So you have plenty of molecules. Now, what are the types of questions asked? The types of questions asked here are that in one, maybe in one column, say acetazolamide. Acetazolamide does what? It inhibits the carbonic anhydrase. Okay. The acetazolamide, what it does is that it inhibits carbonic anhydrase. Then another one can be acetazolamide is used as for treatment of gout also, because acetazolamide decreases carbonic anhydrase, and there is another organ in which carbonic anhydrase is present, and that is your the eyes. Okay, so in eyes, in the eyeball, the formation of aqueous humor, that is with something which is present always, and then aqueous humor formation is decreased by use of acetazolamide, and therefore acetazolamide is also used as for treatment of did I say gout? Okay, for treatment of glaucoma, sorry, for treatment of glaucoma where the pressure in the eyeball is increased, and so that pressure can be decreased by inhibiting the formation of aqueous humor. So acetazolamide can be used for that. Okay, so what we have seen that the structures of acetazolamide and others, I told you that acetazolamide structure is important. Say we have here sulfur, so it is a thiophene. So on this sulfur you have two nitrogens. The positions are 1, 2, 3, 4, and 5. So it is a 1,3,4-diaza or 1,3,4-thiadiazole. On this you have to put the group SO2NH2, and here you have to put the group NHCOCH3. Okay, acetamide function. So your molecule become acetazolamide. You can write it, I mean, other way also. It won't make any difference. That is why it won't make any difference, because here the groups, the numbers are same. Okay, so here if you are putting here, say if you have N and S, you will be giving preference to S. So number will be 1, 2, 3, and 4. Nothing the difference is not there in the structure, only when you are applying the IUPAC. So this molecule is acetazolamide. Now do some changes in this molecule, and your different zolamide molecules will be formed. There is one molecule which we have developed from this, and that was, say, diaminophenamide. So here it was SO2NH2. Here we had Cl, and one was NH2. Okay. This molecule is also inhibitor of carbonic anhydrase. Requirement was, if you see here, I can say that this much group is the aromatic group. So on aromatic group, at one place we have acidic function, at another place we have acidic function. Again and again I am telling that SO2NH2 is an acidic function. Then here it is a NH2. So with this molecule, we got a new class. What was it that new class? That this SO2 and NH2, this way joined by one carbon. Okay, this will join by one carbon. So joining by one carbon, that means here it was N. So joining by one carbon was this one. Okay. What we did is that in most of the molecules, for active molecules, we don't require this Cl, but yes, this Cl is needed. This SO2NH2 is needed. This SO2, if you see here, this is also SO2NH2, but now it has become a part and parcel of the ring system. So now this ring system, benzene fused to 6-membered ring system, in which 6-membered ring system, that means whose name ends with in, 6-membered ring system, which has sulfur and 2 nitrogens. Okay, sulfur and 2 nitrogens. So it will be thiadiazine. Okay, and so if fused to benzene, therefore benzothiadiazine. So you have benzothiadiazine, and it's a derivative. So we are calling it as a benzothiazide. So your class, so we have shortened the name thiazides. And if you reduce this double bond, if you don't put this double bond, you will call it as a hydrothiazide. Okay. Now the very first molecule in this series is chlorothiazide. So here it is chloro, SO2NH2, SO2NH2 is cyclized manner, and then here it will be amino. We remember because we have developed it from chloraminophenamide, and then here you do not have any substitution right now. Your molecule is chlorothiazide. Reduce this double bond, your molecule become hydrochlorothiazide. So chlorothiazide, you can have, say, if you see here, we have aromatic function. On this aromatic function, you have acidic function. You have another acidic function, SO2NH2, another acidic function. Both the functions are meta to each other. Para to one of the acidic function. Yeah, acidic function la tumhi ikade baga. तर इकडे para to acidic function you have chloro group. So you require the presence of electron withdrawing group on the para position. So this N is needed for the next action. Okay, and then lastly we can have plenty of groups present here. Now based on those groups, so it can be your bendroflu, thiazide, flumi, thiazide, etc. So you can have here small alkyl or aryl alkyl group. So your molecules are now thiazide molecules. Now these thiazide molecules, this will not act on carbonic anhydrase now. Okay, they will not act on carbonic anhydrase. Where they will act? They will act on now the transporter system. Which transporter system? They will act on co-transporter system. Which co-transporter system? They will act on now antiport. They will act on now symport system. Which symport? So here, say this is here you have the cell membrane. Okay, cell membrane of not cell membrane. This is the cell of. अरे वहां से बंद करा तुम्ही.
डेपोत नाही सोडून दिलं. नाही चौकात म्हणे.
Please put off your mics. कोण आहे? So this we have the cell of the lumen. Okay, cell of the lumen. Lumen is here it is the nephron. So of that nephron, that tubule. Now this tubule we are talking about the distal convoluted tubule. So this is the cell of distal convoluted tubule. Here is the lumen. इथे पोकळी आहे. ज्या पोकळीमध्ये युरिन तयार होत आहे. इकडे सेल आहे. आता ही सेल काय करते आहे? तर ही सेल सोडियम एक युरिन मधून एक सोडियम आतमध्ये घेते आणि एक सोडियम आतमध्ये घेतल्यावर ती एक क्लोरीन त्याच्याबरोबर आतमध्ये येतो. So it's a sodium Na plus Cl minus. You won't say NaCl. Okay, you won't say sodium chloride. It will be Na plus Cl minus co-transporter. Okay, it is a Na plus Cl minus co-transporter. आता हे आतमध्ये आल्यावरती ह्याच्या बरोबरीने पाणी येणारच आहे. It will be followed by water and therefore urine volume will decrease. Okay, therefore urine volume will decrease. This Na plus and Cl minus will be taken up now again by blood into the blood vessel. What if we inhibit this? If we inhibit the co-transporter of Na plus and Cl minus, it will not come inside the cell. Water will not come inside the cell, and you will not get, or water will remain in this urine only. And what you will get? You will get increase in the urine formation. Okay, so what we have? That thiazide and thiazide-like diuretics, which we have developed from the structure of one of the carbonic anhydrase inhibitor. Now, why we are calling it as a thiazide-like? And the thiazide-like चे जर तुम्ही structure बघितले, salicylamide किंवा chlorothalidone, indapamide, zipamide, हे सगळे जे structures तुम्ही बघितले, then you will see that you have aromatic function. Most of the compounds have SO2NH2 group. That is also there. Most of the compounds have SO2NH2 group. Most of the compounds have electron withdrawing group here, Cl or CF3. most of the compounds have acidic function here, but now not essential that that acidic function will be in the cyclized fashion. जर cyclized fashion मध्ये असला तर मग त्याला आपण thiazide म्हणतो आहे, पण इथे तो सॅलिसिलिक ऍसिड. जर आपण इकडे व्हिडिओ इज ऑफ, एक मिनिट थांबा. If you have this salicylic acid, if you have here CONH2, it will be called as now salicylamide आणि याचा डेरिव्हेटिव्ह तयार करा, त्याचे नाव होते झिपामाइड. ओके, सो दिस वे यू हॅव प्लेंटी ऑफ मॉलिक्युल्स. जर तुमच्याकडे दोन्हीकडे COOH ग्रुप असेल तर त्याला आपण म्हणू थॅलिक ऍसिड. ओके, सपोज इथे आपल्याकडे COOH आणि इकडे CONH2 असेल, त्याला आपण म्हणू थॅलिमाइड. आणि थॅलिमाइड you have chlorthalidone and other molecules belonging to this. So you can see that the structure is not exactly thiazide. म्हणजे benzene fused to thiazine ring system असं स्ट्रक्चर नाही, पण त्यांचे मोड ऑफ ऍक्शन सेमच आहे. ती मोड ऑफ ऍक्शन काय आहे? They are inhibiting the sodium NA+Cl- co-transporter system. ओके, म्हणजे हा झाला तुमचा thiazide and thiazide like diuretics. Then we have spironolactone. Already we have seen the structure of aldosterone. If you don't recall, it's a progesterone. So it's a 19, 20, 21 function. बाकीचे functionalities तुम्ही बघून घ्या. What is most important is that 18th number carbon is CHO, and we have here 11 number carbon OH. So this CHO and 11 number carbon, they are forming the hemiacetal, and this molecule now we call it as a aldosterone. Aldosterone exists at hemiacetal. Now what is the structure of spironolactone? Spironolactone is again in the similar fashion, but what we have here, that we have here the spiro system. Okay, spiro system. So lactone, this carbon is a part and parcel of two ring system at a time. ज्याही मॉलिक्यूल मध्ये एक कार्बन हा दोन रिंग सिस्टमचा पार्ट असतो, एकच हा, दोन नाही. त्याच्यामुळे इथे तो स्पायरल दिसतो आपल्याला, एक असा भिंगरी फिरण्यासारखा. जर आपण त्याचं 3 डिमेन्शनल स्ट्रक्चर बघितलं तर भिंगरी फिरते आहे असं वाटतं, मग म्हणून त्याला आपण स्पायरो कार्बन म्हणतो किंवा स्पिरो, जे काही तुम्हाला प्रोनाउन्स करायचं असेल तर स्पिरो कार्बन म्हणतो. जसं आता फॉर एक्झाम्पल तुमचा अँटी एन्झायटी मॉलिक्यूल आहे बुस्पिरोन. ओके, buspirone belongs to the class of azaspirodicaldiones. So buspirone, spiro कार्बन आहे त्याच्यामध्ये. ओके, ग्रिसिओपल्विन मध्ये सुद्धा स्पिरो कार्बन आहे, इथे सुद्धा स्पिरो कार्बन आहे, म्हणून स्पायरोलॅक्टोन किंवा स्पायरो कार्बन. स्पिरोलॅक्टोन, स्पायरोलॅक्टोन काय म्हणायचं बोला तुम्ही? स्पायरोलॅक्टोन. And here we have the group present with sulfur. Okay, सल्फर कंटेनिंग ग्रुप आहे इथे. तो काय आहे तो आता पुढे तुम्ही बघा. सल्फर कंटेनिंग ग्रुप आहे. स्ट्रक्चर पूर्ण काढलेले नाहीये मी, फक्त जे इम्पॉर्टंट आहे तेवढंच काढलं आहे. सल्फर कंटेनिंग ग्रुप आहे आणि हा मॉलिक्यूल ऍक्टिव्ह मेटाबोलाइट नाहीये. हा मॉलिक्यूल इनॅक्टिव्ह आहे. I won't say inactive. Spironolactone is also active, but it has its metabolite. Its metabolite canrenone is also active. Okay, so canrenone and spironolactone both are active molecules. Okay, so we have the compound spiro compound. Now what was remaining? Trimetherine. Okay, I was asking you that day about trimetherine. Trimetherine, it is a pteridine derivative. If you remember, pteridine derivative is two ring system. Two benzene rings are fused, and then there are 4 total nitrogens. So if you write the structure, one ring is pyrimidine, another ring system is pyrazine. Okay, so it is a pyrimidine fused to pyrazine, so that molecule becomes pteridine. Now in pteridine molecule, in pteridine molecule, if triempterin, so we require the presence of 3 amino groups. मग आता फक्त तुमच्याकडे 4च पोझिशन्स आहेत जिथे तुम्ही अमायनो ग्रुप्स टाकू शकता. आणि ट्राएम्टेरिन तिसरा चौथा जो ग्रुप आहे तो ऑटोमॅटिकली तो क्लोरीनने so we have here the questions are always asked on spironolactone, triempterin. So pay attention. Say for example, हा तुमचा दोन रिंग सिस्टम्स आहे. So here is pyrimidine ring system and here it is pyrazine ring system. Is it visible? Okay. So here you have pteridine ring system. On this pteridine ring system, you have to put the amino groups. Say here it will be one amino group. They just आता तुम्हाला कुठे पाहिजे ते बघायला पाहिजे. Amino group and chloro group. Your molecule. Okay, so we have here another molecule of in this class is amiloride. Okay, now amiloride molecule is a pyrazine. Amiloride molecule is pyrazine. Can you write the structure of pyrazine? मी आत्ताच सांगितलं होतं तुम्हाला. Amiloride is pyrazine. क्लोरो की फिनाइल त्या दिवशी काय बोलले होते रे मी बाबा, तुम्हाला कोणाला आठवतंय का? ट्राएम्टेरिन क्लोरो नाहीये, फिनाइल आहे बहुतेक. हा चेक करून घ्या. फिनाइल आहे, मला आठवतं फिनाइल म्हटले होते. ओके, आता फक्त कुठल्या पोझिशनला आहे तो बघायचा. सो वी हॅव हियर triempterin molecule. Okay, now amiloride is also of the similar kind, but it has now only pyrazine system. Pyrazine, that means 2 nitrogens at 1 and 4 position. Amino group. Okay, so we have here amino, chloro, and then we have here C double bond O, and the guanidine function, it is NH C double bond O NH2. So what your molecule? Okay, loop diuretics, ethacrynic acid and furosemide. Furosemide किंवा frusemide दोन्ही नावं आहेत. So these molecules are inhibitors of Na plus K plus 2Cl minus co-transporter. हे कुठे आहेत तर हे सेल मेम्ब्रेन वरती आहेत. कुठल्या सेल मेम्ब्रेन वरती तर थिक असेंडिंग लिंब ऑफ लूप ऑफ हेनले जो आहे त्याच्या सेल मेम्ब्रेन वरती Na plus K plus 2Cl minus ट्रान्सपोर्टर आहेत. ते काय करतात, ते Na plus ला घेतात, ते Cl minus ला घेतात, Na plus आणि Na plus ला घेतात, त्याच्याबरोबर Cl minus येणारच आहे. त्याचबरोबर एका K plus ला घेतात, त्याच्याबरोबर Cl minus येणार आहे. म्हणजेच ओव्हरऑल व्हॉट दे आर डुईंग इज दॅट they are taking Na plus, K plus and 2Cl minus from urine into the cell and later on to blood. So if you inhibit this transporter, you will get highest diuretic activity. Okay, पण आता जर मग आपण जर हे इनहिबिट केले तर हे इनहिबिट केल्यावरती कॅल्शियम आणि मॅग्नेशियम यांचा सुद्धा यांचं रिअब्सॉर्प्शन कमी होतं. हे सुद्धा एक्सक्रीट केले जातात आणि म्हणून सगळेच सॉल्ट जर आपण लूप डायरेटिक वापरले तर नॉट ओनली सोडियम पोटॅशियम बट ऑल्सो कॅल्शियम अँड मॅग्नेशियम ऑल्सो. म्हणून त्याला सॅल्युरेटिक ऍक्टिव्हिटी अशी असंही म्हणतात. सॅल रिलेटेड टू सॉल्ट. So saliuretic activity, these compounds increase the excretion of salt also. आता तुमचे कुठले कंपाउंड्स आहेत की जे डायुरेटिक म्हणून one is ethacrynic acid. Okay, one compound is ethacrynic acid, and second compound, say I will say furosemide or torsemide. आता what the molecule ethacrynic acid is. आता जर ethacrynic acid molecule बघितला, it's a acetic acid, it's a phenyl acetic acid. What we have here? CH2 COOH. Here you have phenyl group, so here it is a phenyl acetic acid. On this we have the acrinic group, so we have here C. आपण पुढे बघूया. मी एक मिनिट माझ्या डोक्यातनं गेलं. एक दोनच मिनिट. It has acryl group. It has a acrinic acid. CO, it is phenyl acetic acid, dichlorophenyl acetic acid. It's a acrinic acid, C double bond O acryl group, and then it has ethyl group. मी फक्त क्रॉस चेक, तुम्ही एक क्रॉस चेक करून घ्या स्ट्रक्चर. C double bond C, and here we have ethyl group. So what we have? CH2 dichloro. So this is the structure of acrilic acid, ethyl acryl group. The group is this group is acryl group. So ethyl acryl group, and then phenyl acetic acid. So ethacrynic acid. Okay. Another molecule, say for example, bola. Acetic acid, CH3COH. Phenyl acetic acid. Here it is phenyl group. So it will be CH2COH. Acryl group. Here you require acryl group. On this acryl group, you need presence of. It has कुठे पाहिजे, नंबर 1 ला पाहिजे, नंबर 2 ला पाहिजे की नंबर 3 ला पाहिजे, तो आपण बघूया. Dichloro, it's a dichlorophenyl acetic acid करून जातो. Ethyl group we have to put now. So that will be ethyl, there will be CH2. Okay. So we have this molecule will be ethacrynic acid. Now I'm just asking you, check where to put the ethyl group, whether to put on here. Three position. Okay. The ethyl group is acidic function पाहिजे ना आपल्याला. Okay. What we do here is that this group is C1. Okay. म्हणजे आता हा काय झाला? This total group will be acroyl group. ACROYL. Acroyl group. And then you have here ethyl group present here. So this becomes ethyl ethacrynic acid. Okay. So ethacrynic acid or ethacrynic acid. It is an ethacrynic acid. Ethyl group is present. So again, if you see here, this function CH2COOH is CH2COOH is acidic in nature. कोणी स्ट्रक्चर बघताय का? मला थोडंसं हे झाल्यासारखं वाटतंय याच्यात. I think that there is this, it is not phenyl acetic acid, it is phenoxyacetic acid, CH2COOH. Okay, so we have here this acidic function with oxygen, acidic function, O, CH2COOH, 2 chloro group, and then again here acidic function. So the similar motif, that is presence of aromatic function, presence of two acidic functions on this aromatic function, that is conserved in ethacrynic acid. Okay, so we have ethacrynic, but and then why this change is needed? This change is needed because we require the compound to be active only on a thick ascending lip of inlet, and on that cell membrane of these cells we have presence of Na plus K plus 2Cl minus 4 transporter. मग तसंच तुमच्याकडे मॉलिक्यूल आहे फ्रुसेमाइड मॉलिक्यूल. ओके, आता इकडे तुमचे वेगवेगळे another common पिरिडिल स्ट्रक्चर पिरिडिल आणि त्याच्या या पोझिशनला असिडिक फंक्शन आहे दॅट इज SO2 NH2 ओके and here we have amino function similar to that of diaminophenamide आणि मग इथे this group is with toluene group contains spices. So here it is NH, here it is phenyl, phenyl vertical. It is becoming now this function is SO2 tertiary butane. Torsemide चे T वर्ण torsemide tertiary butane isopropyl CH3 okay torsemide toluene function amide function sulfonamide function. So we have here torsemide molecule which is also the potassium which is also the inhibitor of Na plus K plus 2Cl minus co-transporter. Okay. आता सगळे लूप डायरेटिक्स जे असतील ते सगळेच्या सगळे आयन्स G प्लस प्लस Ca प्लस प्लस यांना शरीराच्या बाहेर टाकतील वाढवतील आणि त्याच्या मागे मागे Cl मायनस येणारच आहे. सो दीज आर Na प्लस K प्लस Mg प्लस प्लस Ca मायनस मायनस ह्या इलेक्ट्रोलाइट्सच्या इम्बॅलन्समुळे बाकीचे ऍडव्हर्स इफेक्ट्स दिसतील. त्याच्यामुळे लूप डायरेटिक्स potassium sparing diuretics and thiazide like diuretics. Potassium sparing diuretic potassium sparing का म्हणतोय आपण की कलेक्टिंग डक्ट्स वरती काम केल्यामुळे किंवा अल्डोस्टेरॉन वरती काम केल्यामुळे अल्डोस्टेरॉनचा रोल फक्त Na+ चा एक्सक्रीशन वाढवणं आहे. मग आपण अल्डोस्टेरॉनचं काम कमी केलं तर Na+ चं एक्सक्रीशन कमी होईल फक्त पोटॅशियमचं काहीही होणार नाही आणि अल्डोस्टेरॉन अँटागोन वाढेल पाण्याचं एक्सक्रीशन वाढेल whereas पोटॅशियम विल बी स्पेअर्ड पोटॅशियम शरीरातच राहतील म्हणून त्यांना पोटॅशियम स्पेअरिंग डायरेटिक्स ओके स्पेअर मी the activity of potassium the concentration of potassium doesn't get affected. मग तुमचे जे कलेक्टिंग डक्ट्स वरती काम करणारे कंपाऊंड्स आहेत those are potassium sparing diuretic whereas all others are they will be affecting acetazolamide करणार नाही because they affect only sodium they do not affect the other ions but loop diuretics आणि काही प्रमाणामध्ये thiazide and thiazide like diuretics हे Na आणि Cl चे एक्सक्रीशन वाढवतात. लूप डायरेटिक्स हे K प्लस चं पण एक्सक्रीशन वाढवतात. thiazide खूप कमी करतं but they also inhibit K they also increase K plus excretion. ओके मग आता अशा प्रकारे हा तुम्हाला चॅप्टर छोटा आहे पण कंटेंट भरपूर आहे. याच्यामध्ये सगळ्या प्रकारचे कंटेंट महत्वाचे आहेत. यात केमिस्ट्री महत्वाची आहे नॉमिनिक्लेचर पण येऊ शकतं ऍडव्हर्स इफेक्ट महत्वाचे आहे साइट कुठली साइट आहे आणि काय आहे हे सुद्धा महत्वाचं. Compounds acting on that and then lastly the vaptans will be related to vasopressin antagonist. Vasopressin is a hormone secreted by आता मला त्या ग्लँडचं नाव सांगा की vasopressin कुठली ग्लँड सिक्रेट करते क्वेश्चन कॅन बी आस्क्ड. ओके मग त्या ग्लँड मधून सिक्रेट होऊन त्याचे ऍक्शन होते किडनी वरती आणि it acts as an antidiuretic hormone. It decreases formation of urine, therefore it increases blood volume and therefore blood pressure, whereas the rest of the antagonist will vasopressin molecule will act on the vasopressin receptors and therefore will inhibit action of vasopressin and will of urine. This is how the chapter of this is how the chapter of diuretics will be studied.